This lesson is over the set of real numbers. It's important to know the different categories numbers are classified under, just because you never know when you're going to be reading over a problem that deals with them. It may mention integers, irrational or rational numbers. So it's just important to know the definitions and some examples underneath each set. So we start with real numbers. And depending on what level of math you're at, there's going to be letters to represent them. So in real numbers, we just use a capital R, kind of scripted, or we might see, when you get to the college level, a symbol that looks like this. So these are both ways to just use a letter, an initial, to represent real numbers. So right now, real numbers is just any number that we know of. When you get to an Algebra 2 level, there are something called imaginary numbers, complex numbers that we're going to work with. But for this lesson, we're keeping it at that pre-algebra level and just talking about the set of real numbers. So these are classified or immediately separated into two sets. First, we'll call them rational numbers. And then we also have irrational numbers. I want to first talk about irrational numbers. Irrational numbers, for right now, I'm just going to use a capital I for them. And you'll see why when we start to talk about some other initials to represent different numbers here. But irrational numbers, the most common is pi. And that's because of right now, we just approximate it mostly at 3.14, but it goes a little further, 1592, and so on. Could be the square root of 2, the square root of 7, even the square root of 6. I just like to describe these as the square roots of non-perfect squares. The reason I say this is because every number here, well, 2's prime, 7's prime, radical 6 or square root of 6 could be simplified into the product of two prime numbers underneath the radical. So it's pretty much the square root of any prime number, or that which could be factored into prime numbers. So all of these are going to be irrational numbers. And the description here is any number in decimal form. So I'm just going to call it a decimal, even if it's like a 1.414. So I'm just going to look at this as any decimal that does not end and does not repeat. Another way to refer to this as non-terminating, non-ending. So it just keeps going on and on. There's no pattern to it. There's no repetition to it. So in a decimal form, it could just be 1.718965347. I mean, it just keeps going on and on there. So that would be an irrational. All of these are examples of irrational numbers. For rational numbers, we sometimes, or majority of the time, see the letter Q to represent rational numbers. And this is because the definition here, it is the quotient of two integers. And later on, I'll explain what integers are. In a different lesson, I did that as well. The quotient of two integers. So let's say we have just P over Q, where P and Q are two integers. It could be 1 over 2. It could be negative 1 over 2. It could be negative 3 over 1, which does simplify just into negative 3. So any number that can be written as a fraction. Looking at the description that we have over here for irrational numbers, it is simply any decimal form, any number in decimal form, that does terminate or end, or repeats. So for instance, if I do have -3/1, which turns into -3, we would call that a terminating number, terminating decimal, even though we really don't see a decimal point. If I had a 1/2, that's just 0.5, and that also just ends. If we see, say, a 1/3, that's actually 0.3 repeating. So we see that repeating bar over it. So again, notice a difference here. This will go on forever. It doesn't end, but it does repeat. These numbers over here end. Over here, going back to irrational, non-terminating, non-repeating decimals there. So that's the biggest difference between the two. So there are no subgroups or continuation of numbers underneath irrational, but if we tend to look at rational, we can simplify this a little further as well. So the next item up, the next type, are integers. I'm going to use a J, or what's more commonly known here is a Z. In college level, I think they tend to go to Z a little bit more. We use J or Z because the I was already over there for irrational. So we're going to use a different letter of the alphabet here. But pretty much integers are, if we look back up here at rationals, if we took away all the fractions and decimals, we're left with integers. So the best way to describe this is the set of whole numbers and their opposites. I know I haven't talked about whole numbers yet. I'll talk about that next, but pretty much the set of whole numbers start with 0, 1. Notice there's no fractions or decimals in between, 2, 3, and so on. So these are the set of whole numbers, and over here be their opposites. -1, -2, -3, and so on. So again, notice there's no fractions or decimals here. So if we took all of those out from the set of rational numbers, we have the set of integers. All right, if we took away the negatives here, we have the set of whole numbers. We use a W for whole numbers. And these are just the numbers 0, 1, 2, 3, and so on. After that, we have what we call the set of counting numbers or natural numbers. And we'll use an N to represent that. And the only difference here is, what do we start counting with? A 1. So we have 1, 2, 3, and so on. So slight differences here. The only difference between whole numbers and natural numbers is that whole numbers contain a 0, natural numbers don't. So in certain situations, we would describe a number as natural and not a whole number. We have to understand whole numbers, because if we have whole items, it is possible to have nothing, no item of that amount. So we would have a 0 show up there. Integers are also important to know when we go to add and subtract integers, which is another lesson I recorded and posted. These are the sets of whole numbers and their opposites. To know the difference between rational and irrational numbers, that will come into play when we go to talk about simplifying radicals, what we can add and subtract. And just knowing all of these are contained under the set of real numbers. All right, so I hope you liked this video. Let me know if you need videos posted about any other topic, and please keep on looking at other videos I have posted. Reach out to me if you have any questions at thealgebratutor.com. Thank you.